Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are discussing the protective textiles for hazardous gases and chemicals. In last session, we have discussed the smart and advanced protective textiles, and there are different aspects we are discussing. So, embedded sensors in chemical protection protective suits we have discussed, which actually enables a real time detection technology. So, that can sense the presence of hazardous gas due to any leakage, and accordingly we can take protective actions. Now, gas detection textiles are very important. Here we can do it by flexible monitoring system. So, porous sensors actually continuously monitor the ambient air for its toxic gas presence. So, the networks are connected. So, real time hazard alert transmitted through the communication system. So, critical protections are there essential for emergency responses and for military personnel in hostile environment. So, this type of smart gas protective systems are important for emergency responses. So, color change hazard detectors that we have discussed, we use to get the visual warning. So, different types of dyes, color sensitive, pH sensitive dyes are used to sense the pH. It will change the color with the change in pH. It will sense whether presence of acidic and alkaline nature and what is the intensity. So, that everything it will be sensed. So, industrial scale stamping on normal polyester fabrics are there. Now, the future of intelligent hazmat suits. So, AI driven sensor network. So, that will actually enable the take the environmental data and predict the hazards before exposure. So, this system data driven system. So, any environment it can predict the hazard, accordingly that that suit we can use real time hazard mapping. So, integrated system creates live contamination map. Okay. So, real time hazard mapping. So, what is the contamination present in the air and what type of gases are there, that will map. And autonomous response capability. So, suits automatically adjust protection level by adjusting the this pore size depending on the type of threats. So, and alert the and coordinate with the centers. So, different types of autonomous response systems are can be incorporated. So, there are different commercial deployment by different universities are there. Okay. The main vision is the fully integrated smart textiles that monitor the environment and the wearer's health and suit integrity. So, this type of integrated systems are there for future protective textiles. So, smart and advanced protective textiles So, intelligent fabrics and embedded sensors are used and which transforms the traditional protective gear into sophisticated life saving system. So, that if we integrate the different types of sensor that can sense different responses and accordingly it will the protection capability will increase. So, it will monitor, detect and respond to the environmental hazard in real time. So, different types of sensors can be embedded. So, embedded sensors in chemical protective suits. So, apart from the gas sensor, so for chemical protection we can embed different types of sensors. So, real time detection technologies are adopted. So, to detect the chemical penetration in real time using e-textile the integrated metal organic frameworks. So, which alerts the wearer instantly to any hazard leak through the audible or haptic warning. So, different types of warning systems can be embedded. So, that is with the help of integrated metal organic frameworks. So, this advanced fabric combined the critical functions. What are these functions? The sensing of chemical threat, okay. Then capturing the dangerous molecules and filter the toxic gases like nitric oxide or hydrogen sulfide. So, this type of gases can be filtered out. The gas detection can be done through the textiles. So, the smart integration sensor integration should be there. So, continuous monitoring to detect the presence of gas, flexible porous sensors. So, that this woven directly onto the fabric. So, for the continuous monitoring okay, in the ambient air for toxic gases at concentration as low as a part per billion. So, even the toxic gas is concentration is very very low. In that case also the sensor would be capable of sensing this type of gases. So, network integration is important here. So, connected to the wireless. So, that this sensor send the signal to the control room and instant hazard alert is transmitted to the entire team simultaneously. So, control room as well as the entire team, so that they can get alert, and the critical applications are for emergency response, military personnel, industrial worker. So, different types of places we can use for unpredictable chemical environment. Color change hazard indicators. So, halochromic technology is there, pH sensitive dyes as we have already mentioned. So, industrial scale production can be done. So, they are like high speed stamping of these chemical sensors on polyester fabrics are done. Intuitive alerts. So, here basically no electronics are required, because only the that pH sensitive dyes are required. So, standards testing and certification for chemical protective equipments. So, there are different standards available. So, there are comprehensive guidelines to international standards, testing protocols and certification requirement for chemical hazard, chemical protective clothing. So, these standards are different types of standards are there, like European standards for protective suits. So, European standard EN 943, it is basically it is for gas tight suits. So, gas tight suits means the permeability is not there. So, it provides the highest level of protection against gaseous chemicals and vapor. So, this is termed as type 1 suits, which ensure complete encapsulation of the person wearer with positive pressure. So, there will be complete encapsulation. So, there is no gas permeability. So, this is called type 1 suit with a maximum protection level, like EN 14605, which is basically for type 3 and type 4 level of protection. This is called liquid tight. Earlier 943, EN 943 was gas tight. So, it is not its protection against any gaseous chemicals or vapors, but liquid light is chemical protective suits designed to protect against pressurized liquid jet and spray application. Okay. So, this is for liquid and for gas EN 943. Another is that EN 13982, which is actually for the particulate protection suits safeguarding against a solid airborne particle or dust. So, that is type 5. So, protection against hazardous dry particles and aerosol. Okay. So, the gas and chemical protection. So, there are different types, that may be a particle type, hazardous particles, hazardous gas with a very small particle size or vapor, or even in the liquid form. So, for all this we have different types of standards. So, hand and material protection standards. So, these are the hand protection, there are for gloves. So, there are different types of standards. So, EN 374 chemical gloves are used. So, comprehensive standards for protective gloves against chemical and microorganism. So, these are of 3 types. Type A is minimum 30 minutes permeation for 6 chemicals. Okay. Minimum 30 minutes should be there, and type B minimum 30 minutes permeation for 3 chemicals, type C minimum 10 minutes permeation for 1 chemical. So, this includes specific pictograms and chemical code letter for clear identification of the protection capability. So, there will be different types of codes imprinted on the gloves, which will show the capability of the particular material. So, in America, North American testing standards, so ASTM F739, as per this standard, the permeation of liquid and gas through the protective clothing, that is tested, of liquids and both liquids and gases, okay, widely used in North America for evaluating chemical resistance or establishing breakthrough curves. Then NFPA 1991, which is for vapor protective ensembles for hazmat operation. So, this is the highest level of respiratory, skin and eye protection against solid, liquid and gaseous contaminants. So, both gas and chemical protection, if we want to test, it is NFPA 1991, then NFPA 1992, it is for liquid chemical splash, the splash protective textile. So, for different protection against the liquid chemical splash, and here this does not consider any gas or vapor exposure. NFPA 1994. So, this is CBRN test where chemical, biological, radiological and nuclear exposure. For that, this includes cases 2, 3 and 4 for various threat level. These different classes are there. So, class 2, 3 or 4 we can classify depending on the threat level. And also ISO system, ISO 16602 protection level. Here type 1A and B, that is for gas tight suits. For European standard also there was a gas tight suits, there is a standard. For ISO 9000, ISO standard 16602, it is a type 1A, 1B, it is for gas tight suits, okay, and it is a for inside it is a 1A and for outside it is 1B. Then type 3, which is liquid tight, okay, gas tight is for tight 1A, 1B, and for liquid tight connections between suits elements. So, that is a type 3. So, if the in an element there will be stitches. So, through that there should not be any liquid penetration. Type 4, it is a spray tight protection against liquid aerosol or like any chemical. So, type 4 penetration, if you want to know, so we have to test through this system. And type 5 protection, that is protection against airborne solid particulates. So, we are not going in details of this test methods, but if we know this type of tests are required, so that we can always refer to this all these standards. Type 6 is there, so limited protection against a light liquid splash. Okay. So, this is the for in case of any light liquid limited protection there, if there is any light liquid splash. So, there we use type 6. So, type 1A and 1B are extreme protection, and type C is the limited protection. So, critical material performance tests are also there. So, breakthrough time test. So, we can measure breakthrough time. So, this measures the elapsed time between the initial contact of the chemical with the protective textile. So, there is a protective, this is a protective textiles. So, one chemical is under contact with the this textile. So, T1 is the time required, initial time of contact, and then it is a detection at the inner surface. Then we have some sensor will be there, and here as soon as it is detecting, the time T2 will be there. So, del T is the breakthrough time, which is nothing but T2 minus T1. This is the breakthrough time. So, critical for determining the safe exposure duration. So, it will give us idea about the how long one will be safe for exposure against this type of chemicals. So, here during laboratory test or during any condition situation, we should use this type of test. Degradation testing. So, when one material like protective textiles come under contact with the different types of chemical, it may degrade. So, evaluation of physical changes in protective material after the chemical exposure. So, what is this? This includes loss in tensile strength, amount of swelling, discoloration or brittleness, that is degradation of the molecule. So, these are required because this ultimately the barrier property, the property of this textile, if it get if it changes, that is if its strength drops, that if it swells, if discolors or maybe brittleness is occurring, then the performance will be affected. So, the degradation testing is important, and then is penetration resistance. So, how those textile is resisting any penetration of any chemical, and that is also very important. The test ability to of the material, this is how much it resist any chemicals penetration. The test the ability of the material to resist chemical pass through the pores, seams and imperfections. So, during the in a test, so during the test of this textile material, protective textile, so through the pores, through the joining. So, this is one, and here is a joining, seam is there, and then another textile is there. Suppose this is other part. So, between the join, at the join, the seam part. So, the chemical may penetrate if there is an opening, and even any imperfection. So, there is a some defect is there through that portion, how much the chemical penetrates, what is the ability of the material to resist. So, that penetration resistance can be measured. So, advanced testing protocols are adsorption capacity tests is there, then thermal comfort test we can carry out, ergonomic evaluation. So, that this test also has to be performed to assess that its usability. Okay. So, that equipment does not impair the critical job function. So, the person should actually the wearer should perform his job optimally, optimal performance can be achieved. So, functional performance testings, fit and mobility tests are important. So, otherwise that the person when is wearing this protective equipment, standardized movement or posture to evaluate the suit flexibility, joint mobility and the ability to perform the essential task, including the person can climb, then can crawl, okay, and can move fast. So, and can lift someone. So, all the activities the person should do, that is a wear trial technique has to be carried out through this type of protective equipment. So, visual material testing. So, optical evaluate the optical clarity. So, chemical resistance, so anti-fog properties. So, all these tests are required, like particularly these are basically face shield and viewpoint material. So, that for different this type of gas and chemical situation, toxic gas situation. So, that visibility should be there. So, visibility we test here, and chemical splash test, the simulate real world exposure to where the chemical spray is there, different type of chemical splashes are there. So, that type of real time situation is created. So, durability tests, aging tests are important. So, abrasion test, so for different types of abrasion, how the fabrics are performing. Seam testing is important, because the seam slippage or the damage should from the seam part should not happen. So, critical evaluation of sealed and stitch joint where the material pieces are connected. This test includes tensile strength of seam construction, chemical resistance of seam interfaces. So, if the thread sewing thread is not chemically resistant, so that from there may be opening created from that portion. Peel strength and delamination resistance, long term integrity under stress. So, all this mechanical strength and chemical resistance tests are required. Seams often represents the weakest point in the protective equipment and requires rigorous validation. So, if the total protective textile we create, it is with a perfect design, perfect material, but if the seam at the seam, if it is the weak, if it is poor, so in that case total that structure will collapse. Even abrasion resistance is also important, because during the real world application, the rubbing and repeated friction are taking place. So, the material should withstand all these activities. So, even aging, so accelerated aging protocols are to simulate the years of storage. Certification workflow, the example you can see the what is the certification workflow. So, after testing one must get certified. The documentation review, so we should submit the technical specification material database. then next process is it will be tested in the standard laboratory, complete all required standard test which includes permeation, degradation, physical properties, functional performance evaluation. So, everything to be done. So, everything to be done in the laboratory. Then one has to certify the material, okay, and marking will be there, that it is certified as a particular level, particular grade. So, entire certification process typically take 8 to 12 weeks for complete protective ensembles and 4 to 6 weeks for individual components. So, for complete ensemble they have different components, different layers. So, it takes longer time. So, clothing systems for chemical and gas protection. So, a comprehensive technical overview for protective clothing system for chemical, biological, radiological and nuclear environment, from actually fully encapsulated level A to specialized industrial and military application. So, this system, this chemical and gas protection. So, we have different wide range of systems are there, clothing systems are there. So, fully specialized encapsulated level A suits to specialized industrial and military application suits. So, level A which is fully encapsulated gas tight suits. So, that gives maximum protection design. So, level A suits provide highest level of respiratory, skin and eye protection against hazardous vapors, gas and particulates. They are fully encapsulated system which features gas tight construction with shield seams, integrated breathing apparatus. So, integrated breathing apparatus are there. So, the critical components here are self contained breathing apparatus, SCBA. In short, it is called self contained breathing apparatus. That means, you can see this is the self contained breathing apparatus through which person can breathe. So, there it is very important that the breathing has to be there, but there will not be any exposed portion. Okay. Then chemical resistant outer shell. So, this outer shell, this total equipment, the outer shell will be totally chemical resistant. Pressure relieved valve will be there, the outer shell here will be chemical resistant and there will be pressure relief valve for proper breathing. Double layer gloves will be there, there will be double layer glove system used for IDLH, immediate dangers of life, dangers to life or health. So, this is immediately dangerous to life and health, it is called IDLH, that would add IDLH atmosphere where contaminants identification is uncertain. So, we cannot predict the type of contaminants. So, this type of critical situation we need the self-contained breathing apparatus like COVID, exposure to COVID, this type of protective equipment were used. These are critical components. For that we use the level A. Then level B is the liquid tight splash suit, where the liquid will be protected. So, liquid tight constructions are protect against liquid splash, not the vapor. Vapor can penetrate easily, but it will protect us from the liquid splash. So, SCRB is worn extremely, so at the extremely hazardous condition where the liquid penetrates, chances of liquid splashes are there, the chemical splashes there. That type of extreme hazard condition we can use the level B. So, it is externally under the splash resistant outer outer garment we are using. So, material performance, so here multi-layer barriers made of butyl rubber or Viton, okay, this type of fabrics or Tychem fabrics were tested for specific chemicals permeation test. So, that different types of chemical permeation we can test. Then field application we can do. So, ideal for spill response. Okay. So, different types of field trial we can do. Level C, D, which are not neither the gas protection, gas tight or liquid tight, it is a splash protection and it is a limited use. Level C is APR, air purifying respirator with chemical resistant clothing for liquid splash penetration. So, it protects from the liquid splash penetration. Full face or half mask APR, chemical resistant coveralls are used, inner and outer gloves we can use, steel toe boots with covers. So, these are the complete PPE. And level D protection is work uniform, provide minimal protection for nuisance contamination only. So, this for daily use we can use that level D protection. So, this is there is no respiratory protection required beyond normal working, normal clothing system. Coveralls or work uniform is there, safety glasses are used, chemical resistant glasses if it is required, this is optional for level D protection, and steel toes safety footwears are used. So, military CBRN protective systems, the mission critical defense technologies where different types of CBRN suits are there with which integrates advanced filtration, vapor barrier. Okay. Also the joint service general purpose masks are used. Mission oriented protective posture. So, MOF gear configurations, these systems are used. And for industrial chemical suits, okay, which is sector specific solutions are there. So, industrial applications, chemical manufacturing, petroleum refinery, pharmaceutical production. So, there we even agricultural operation and all this type of industries, okay, their specialized protective textile, what type of chemicals they are dealing, what type of gases they are using. So, that so different type of chemicals. So, petroleum refinery they will have different types of chemical, pharmaceutical industries will be they will deal with different types of chemicals. So, industry specific products are should be used. So, here the basic considerations are it should be chemically compatible. So, chemical compatibility should be there and breakthrough time should be, we should know degradation resistance. So, we can test as per ASTM standard. So, acid resistant suit with reinforced seam we can manufacture. For petroleum industries, flash fire protection with vapor barrier. So, for laboratory there are different types of chemicals we use. So, for laboratory we have to use the multi chemical resistant protective clothing for varied exposure, different types of chemicals are used there. So, firefighters chemical protective system, it is again special category here. So, at the firefighter there may be different types of chemical and gases are they are exposed. So, thermal barrier will definitely be there, that we have already discussed in the fire protective textiles part. In part 1 we have discussed this part, and chemical resistance. So, multi threat protection against acid, base, solvent or toxic industrial chemicals. So, when there is a fire, so the prediction of the type of chemical is very difficult, there may be any type of chemical. So, there the multi threat protection is important. So, NFPA certification is required. So, as we have already discussed for vapor protection, liquid splash protection, emergency medical operations are there. Now, to address the sustainability, so we have to we should know the can we reuse. So, reuse the this protective textile versus disposable system. So, should we dispose the system or we should reuse the system after cleaning. So, reusable protective suits are durable. So, we can use multiple time with proper documentation protocol. So, we should know what type of washing, cleaning are required. So, materials are heavy duty butyl rubber coating, ergonomics high So, economics that there will be high cost. So, this due to the reusability and heavy duty butyl rubber or multilayer laminates. So, these are the economically it is a very expensive, higher cost, lower long term expense for frequent use. So, maintenance requires inspection, testing and documentation. So, here after as we are reusing repeated time. So, we should maintain it properly and document it, but for disposable protective suits it is these are the single use material. So, lightweight, okay, and it is a lower cost, upfront cost. So, this is ideal for infrequent or emergency response. So, where we need rarely basically for only for emergency response, there we can use the reusable product, but for daily use we have to use the where frequent use is there, in that case we should use the reusable product. So, the future trends of chemical protective suits are, so breakthrough technology we should adopt. So, breathable chemical barriers. So, the traditional chemical suits trap heat and moisture, that is important, okay, and limiting the wear time and comfort. So, next generation chemical protective clothing are breathable barriers are there. So, using nanotechnology and which use the selective membrane technologies are there to allow the water vapor transmission while blocking the chemical agents. So, advanced polymer membrane with nanoscale pores. So, that enables the thermal comfort. So, enhance comfort and provide full protection. Graphene based CBRN suits are also used. So, here graphene based suits the exceptional strength to weight ratio. So, graphene is 200 times stronger than the steel, multi thread protection, we can get different types of protection from different types of threads like chemical, biological agent, enhanced durability. So, tear resistance, puncture resistance, okay, degradation under extreme conditions. So, that enhanced durability, so that we can use repeatedly. So, repeated usage can be there. So, ultra lightweight smart suits. So, integrated intelligence. So, real time monitoring can be done. So, weight reduction by 30 to 50% compared to conventional suits, which allows for greater mobility and reduce fatigue during the critical operations, like targeted weight is 2.5 kg. So, that ultralight weight smart suit. So, around 2.5 kg with extended duration of use 8 hours, a person can use continuously for 8 hours without any fatigue, and there will be protection typically around 99.9% protection. So, AI driven ergonomic suit designs are also there. So, that will predict the requirement for different conditions. So, data it goes through the data collection, motion capturing and biometric scanning is there, the AI analysis. So, pattern optimization algorithms, then rapid iteration, so virtual testing and refinement. So, we can generate the validate the test design. So, performance optimized suit we can design, so that it can generate, it can give the better ergonomics. So, real time chemical sensing textiles are there, which will sense the through the electronics alert or visual or electronic alert, it will give the alert to the wearer instantaneously. So, that the one can get prepared, detection sensitive down to part by million concentration, multi agent identification without external equipment. So, real time chemical sensing textiles are used. So, regenerative filtration mechanisms are there, active filtration, sustainable operations, self regeneration and extended service life. So, which reduces the replacement frequently and reduces the waste. So, this type of materials are used. So, circularity and sustainability in chemical suits, we can use that instead of disposable material, we can actually reuse the material designed for disassembling. So, we can take out the required part for the reuse, recycled content up to 60% post consumer recycled material in non critical components, that we can use, and take back programs we can adopt. So, there are ergonomic and standards for chemical protective textiles. So, critical ergonomics are mobility and joint flexibility, suit weight and pressure distribution, range of motion we can get, stress management, dexterity. These are the ergonomics part of the protective clothing. So, how the ergonomics are engineered by pattern and structural engineering. So, panel distribution, elastic zone. So, there we can distribute the elastic zone. So, targeted stretch area enhance and which enhance the mobility. Reinforcement, we can reinforce the knee elbow zone, okay, where repeated stress are applied. So, interface optimization, the seam placement is important, zipper design. So, comfort physiology, the human comfort is important, thermal comfort is important. Then sweat accumulation, we should manage the sweat accumulation. Then microclimate control is important, and carbon dioxide built up management. So, in the mask we should manage the carbon dioxide build-up, so that there should not be any breathing problem. So, user centric design principle, anthropometric considerations should be there, gender specific fits depending on the body shape, extended use planning. So, there should not be any problem because of the comfort. So, persons should be ready to able to use this protective clothing for extended time. Cognitive load reduction, so that mental burden should not be there during emergencies. So, user experience integration, so feedback system should be there, so that it should capture the real world insight to drive continuous design improvement. So, the European standards, we have already mentioned that these standards earlier also. There are different types of standards. International standard ISO and ASTM standards are there for this gas and chemical protective clothing. NFPA standards we have mentioned earlier also. Material performance test, breakthrough time penetration, degradation test, adsorption capacity test, physical test, abrasion, aging, seam, performance test, thermal, comfort, fit, mobility. So, material testing, that integrated certification approach, material testing, field validation, ergonomic assessment and standard compliances are required. And we have come to the end of this session, and next we will start the protection from microbiological threat. Till then, thank you.